Good morning friends, I am Jigar Ratnottar from Atmiya Engineering College, Rajkot. Today we are going to solve the GTU question paper of the subject Electrical Circuit 2011. Starting with the topic. The question A, that is the define Ohm's law along with its limitation. George Simon Ohm defined the very important law in a field of electronics. He says that I equals to V by R. It means that whenever you are taking any electronics material with the potential difference V, it has the resistance R. So the current flowing through that device, that is V by R. It means that current is directly proportional to the potential difference of that material, and it is inversely proportional to the resistance of that material, that is R. See here, I is the current measured in ampere, voltage measured in volts, and R, that is resistance, measured in ohms. He also says that if you are aware from any two terms among the three terms, 3 I, V and R, then you can easily find out the third one. Like that, if you are known that the value of V and R, then you are easily find out the value of I by the equation of I equals to V by R. If you are known about the current and the resistance of the material, then you can find out the voltage, that is V equals to I into R. This is the product of current and the resistance. And if you are also known the voltage and the current of the material, then you can find out the resistance of that material, that is R equals to V by I. So this is very important equation in the field of electronics. Says that the voltage V across a resistor is proportional to the current I that flows through it. So in general, the resistance does not depend on the voltage, but the basic law concerning the flow of electricity is Ohm's law. But very small limitation of the Ohm's law is that here we are taking one example of the motor which has the resistor, variable resistor, that is R. This is armature and this is the field. You are applying the variable supply to the motor. So what happens? Actually the limitation of the Ohm's law, that if you are increasing the value of R, then as per the power equation P equals to V into I or I square R, the power loss of that particular device is also increased. So ultimately what happens, the speed of the motor is decreased. So this is the limitation of Ohm's law. If you want to decrease the speed of the motor, then you have to increase the resistance R. But whenever we are increasing the resistor R, then the power loss is also goes very high. And if the power loss is very high, then it directly affects the heat, that is I square RT. So ultimately the heat loss is very increased, and due to that the accuracy of the device is very down. So this is the biggest limitation of Ohm's law. Now we just go through the calculation of any one term using the Ohm's law. See here we are taking one example where we want to calculate the current I flowing through the device. That is a circuit which has the DC battery and connecting with the probes with the bulbs. So the simple circuit diagram is like that. The 1.5 voltage battery is connected with the 2 ohm resistance. So here the two values are known for us, that is the R, that is a 2 ohm, and the voltage, that is V, 1.5 voltage. So our task is to find out the current flowing through that bulb. See here, according to the previous table, that is here the two values are known, V and R. So ultimately the third term, that is I can be find out from the equation I equals to V by R. So V is 1.5 voltage and R is a 2 ohm. So ultimately taking the ratio of 1.5 to the 2 ohm, we are getting the 0.75 ampere. So it means that if you are knowing the two values, then you can easily find out the third one. So the 0.75 ampere current can be flow from the device bulb whenever you are connecting the 1.5 voltage battery to the across the device. Now one video showing the Ohm's law experiment.
Researching on the factors that affect current flow in a battery. He found that the current in a steady state conductor is proportional to the voltage between the ends of the conductor. So if V is the potential difference of this conductor from point A to point B and a current I flows through it, I is proportional to V. What Ohm also discovered was that current is inversely proportional to the resistance offered by a conductor. What is resistance? Imagine a river flowing downstream from a mountain. The river will encounter several rocks and boulders which will block its flow. In other words, the rocks act as a resistance to the flow of the river. Similarly, conductors also offer resistance to the flow of current. So if R is the resistance of the conductor, I is inversely proportional to R. Combining these two terms, we get I is equal to VR or V is equal to IR. The reason why we represent Ohm's law as V is equal to IR is because...
Now the next question, that is the question number 2a. Define the following terms: Coulomb's law, permeability, the magnetic fringing, the Lenz's law, hysteresis, and the Fleming's right hand rule. Now one by one we just go through the defined terms. The first starting with the Coulomb's law. 7 marks. The Coulomb's law states that this is the law gives the force of the attraction or the repulsion between the 2 point charges. So whenever 2 point charges Q1 and Q2 are connect together with each other, then exactly what happens, they are attracted with each other or they are repelled with each other. You can easily find out from the Coulomb's law. Taking with the example, if the 2 points charges, the Q1 and Q2 are separate by a distance, sum of the distance, that is R, then the magnitude of the force, repulsion or the attraction between them is given by the equation, that is F equals to K, that is a constant, Q1 Q2 by R square. K is a Boltzmann constant. So by applying this equation, you can easily find out that the force charges are the repulsion with each other or they are attracted with each other. Now just taking one example of the Coulomb's law.
Let's have a discussion on Coulomb's law. This fundamental law of electrical science is also referred as inverse square law. According to this law, if two charged bodies are kept at a certain distance, they will experience an attractive or repulsive force depending upon the nature of their charges. If the bodies are charged by similar electrical charge, they will repel each other. If the bodies are charged by opposite electrical charge, they will attract each other. Suppose one body is positively charged with plus Q1 and the other body is negatively charged with minus Q2. The force acting between them is attractive. Again, one body is positively charged with plus Q1 and other body is positively charged with plus Q2. The force acting between them is repulsive. Again, one body is negatively charged with minus Q1 and other body is negatively charged with minus Q2. The force acting between them is again repulsive. The force is a vector quantity, which means it has direction in addition to its magnitude. Here the force acts along the straight line joining the centers of the charged bodies. Now if you increase the charge Q1 keeping Q2 unchanged, the force is obviously increased. If you decrease the charge Q1 keeping Q2 unchanged, the force is obviously decreased. Similarly, if you increase the charge Q2 keeping Q1 unchanged, the force between them is again increased. If you decrease the charge Q2 keeping Q1 unchanged, the force is obviously decreased. According to Coulomb's law, force F between them is directly proportional to either Q1 or Q2, or in other words, F is proportional to the product of Q1 and Q2. Now, by keeping their charge fixed at Q1 and Q2, if we bring the charged bodies nearer to each other, the force between them increases. And if we take them away from each other, the force between them decreases. If the distance between their centers is r, it can be proved that force acting on them is inversely proportional to r square. It is also obvious that this force is not same for every medium. For example, if the bodies are kept in air, the force is different from the force while they are kept in water. Variation of force according to the medium is determined by a constant. Say this is K. Finally, we can say that force F equals Q1 into Q2 divided by K into R square. This is nothing but the expression of Coulomb's law. In SI system, force is measured in Newton, distance is measured in meter, charge is measured in Coulomb, and K equals 4 pi epsilon 0 epsilon r. The force acting between the charge is expressed as F equal to Q1 into Q2 divided by 4 pi epsilon 0 epsilon r into r square, where epsilon 0 is the permittivity of air or vacuum and its value is 8.854 into 10 to the power of minus 12 farads per meter, and epsilon r is the relative permittivity of the surrounding medium in respect to the permittivity of air or vacuum. So hope this discussion helped in better understanding of Coulomb's law.
So ultimately the Coulomb's law is very useful whenever you have to find out that the two charge carriers with each other, they are repelled or they are attracted with each other. So you can use the Coulomb's law. Now move towards the Lenz's law. The Lenz's law principle states that the direction of the current induced in a circuit by changing the magnetic field is such that the magnetic field produced by this current will oppose the original field. So whenever any current can be flowing through the induced circuit, then the magnetic field produced by that circuit, so due to the current, that will oppose the original field. This is said by the Lenz's law. Now just go through one of the example of the Lenz's law, which already gives you the basic idea of the Lenz's law.
Magnetic permeability in electromagnetism. Permeability is the measure of the ability of a material to support the formation.
Now just go through the permeability of the magnetic field or magnetic material. So in electromagnetism, the permeability is the measure of the ability of a material to support the formation of the magnetic field within itself. It means that whenever you are talking about any magnetic material, then you have to just find out the capability of that material to produce the magnetism. So with using the permeability, we can easily say about the magnetism of that particular magnetic material. In other words, it is the degree of the magnetization that a material obtained in a response to an applied magnetic field. So how much amount of the magnetic field can be generated with using that magnetic material can also be said from the permeability. So the magnetic permeability is typically represented by the Greek letter, that is mu.
Experimental verification of
This is the
Lenz's
videos
law.
of Lenz's law.
Faraday's second law indicates that the induced EMF and the change in magnetic flux have opposite algebraic signs. HFE Lenz gave the correct physical interpretation of this law and this interpretation is known as Lenz's law. Lenz's law states that the direction of induced current is such as to oppose the very cause producing it. In other words, the induced current will appear in such a direction that it opposes the change in magnetic flux responsible for its generation. Let's now prove Lenz's law experimentally. Connect a coil of few turns to a battery through a sensitive galvanometer and a two-way key.
Now the Fleming's right-hand rule. Fleming gives the two rules of the left-hand rule and the right-hand rule about the current passing through the device. Now the Fleming's right-hand rule states that it shows that the direction of the induced current when a conductor moves in a magnetic field. So whenever in any magnetic field you are moving just one conductor which has the conductivity, then the rule is find out that how much amount of the current will be generated in the direction of the current in particular circuit. So the right hand is held, so you have to just put the right hand with like that, your middle finger, your thumb and the first finger they all are in the perpendicular with each other. So the right hand that held with the thumb, the first finger and the second finger mutually perpendicular to each other. So ultimately what happens, the thumb which represent the direction of the motion of the conductor. So whatever your motion of the conductor is depends on the movement of your the direction of your thumb. Now the first finger that represent the direction of the field, with using that magnetic material, the first finger represent the direction of the magnetic field generated with that material, and the second finger which is perpendicular with the first finger that represent the direction of the induced generated current. The movement is such like that. See, this is the figure where the thumb is with the perpendicular with the first finger and the first finger which is perpendicular or the 90 degree with the first finger. The second finger is the perpendicular with the first finger. So your thumb is represent the movement of the motion of the conductor. Then the first finger that is a magnetic field generated using that conductor, and the second finger which is which represent the